Alrighty, let's see what we have tonight. Check if there is a valid path in a grid medium. You're given an n by n grid. Each cell of grid represents a street. The street of grid ij, the street of grid I at position ij can be 1, which means the street connecting the left and right cell, 2, which means the street connecting the upper cell and the lower cell, 3, okay, so this is like intersections, connecting left and lower, right and lower, left and upper, right and upper. Okay, yeah. You initially start the street at the upper left cell 0, 0, and a valid path in the grid is the path that starts in the upper left cell and ends at the bottom right. The path should only follow the streets. Notice that you're not allowed to change any street. Return true if there's a valid path in the grid or false otherwise. I see. So this is true. And then this would be false. And 1, 1, 2 would be false. Okay. Alright, seems simple enough. Or maybe not simple is maybe the wrong word. Seems understandable enough. Very similar to yesterday's. So yeah, so it's just going to be some sort of stack where I push onto the stack the next position. Yeah. So I think it's going to be something like scene, let's say rows and columns as my default variables for the sizing of the grid. Length of grid is number of rows, length of grid at 0 is number of columns. And just like yesterday, I'm going to have a scene which maps the position to the distance that that is traveled from the shortest distance traveled from the start to that position, I think. So it's going to be, let's say, -1 times the number of columns for every row. And this will map position to distance of shortest path to that shortest path from start to that position. So like I've seen at row 1, column 2 is 3, that means that the shortest path from 0, 0 to 1, 2 is 3. And obviously scene at 0, 0 should be 0. And then I'll have some sort of process. Process stack or process queue. Probably want to do a process queue, maybe. If I do a process queue, then it'll process everything from the shortest distance to the longest. So delimit queue 0, 0. So queue takes an array, or maybe could also take a set. No, it has to take an array, right? Because it has to be ordered. And this array has just the starting position. Probably need some sort of directionality. Okay. So it needs to map a particular street type to the direction it can move to. Okay, let me think. What's the best way of doing this? I guess maybe yeah, I guess maybe it's just gonna be kind of wordy here. Delta is gonna map, let's say, street 1 to moving left, right, so that's changing. It should be in theory changing the X. Grid at row, then column. Row, column. So this changes the column. So no change in the row, so 0, -1, and 0, +1. 0 is a change in row, 1 is a change in column. I wonder if we should be mapping it to an array. Guess it doesn't really matter. Two maps to up, down. So this is just going to be 1, 0, and -1, 0. 3 maps to moving left. So change in rows 0, change in columns -1. Moving down, change in row is +1, change in column 0. And then 4 moving down is going to be 1, 0. And moving right is going to be 0, +1 for column. 5 moving left is -1, no, same row, -1 for column. Moving up is same, -1 for row, same column. And then lastly, street 6 moving up is -1 row, 0 column. Moving right is 0, +1 column. Okay, so those are the mapping of the street type to the direction, to a list of like DRDC, changing delta R, delta C. Okay. So let's go and just put this at the top, I think. Okay, so while process, let's say row column is equal to, I think I need to have distance actually. Row column distance is equal to process pop left from the queue, take the top, and then let's say street, I'm going to say street num is grid at this row column, and then the street number affects what changes I can do. So for every DRDC in deltas of the street num, which should be like this list or this list, I do need to do the hack that prevents it going out of bounds. But I'll do that a bit later. NRNC is the new row, new column, which is the row plus dr, column plus dc. And then if let's say if I guess I can do if the scene at NRNC is equal to -1, so haven't been seen before, and seen at NRNC I actually can't, I can never actually oh, I'm thinking about this wrong. I am definitely thinking about this wrong. So this thing can lead here, but then I have to double check this thing can lead back. So maybe I don't even need a deck, I just need to do a single traversal. Because it can only move forward if it connects to the previous, and each tile is actually only, it's not like that one board game where there's a tile that connects to multiple, more than 2 input outputs to the tile. Casserone, I forget what the board game's called. So maybe, let me think. So this thing can lead to here. One can go here. I would need to check. I would need to check if the grid at that location can traverse backwards. Yeah, I think maybe I should actually do a set here. Yep, I think I need to do a set. Because I'm going to have to use like some sort of reverse logic. And it would need to see if the reverse kind of direction is part of the street values, or the part of the set of things at the next location. Okay. Okay, so I don't think I need a while loop actually, I think I just need a for loop. Or maybe a current. What do I need? Guess a while loop is fine, to be honest. It just needs to have a like current and a, it just needs a while true, I think. Yeah. And I think I need to have like a current is equal to position 0, 0. Okay. So it's maybe 0, 0, 0. Okay, so for every direction that you can move from the street, then I think I need to do an actual, maybe I can't do that hack. If find is valid position-wise, row is an int, column is an int, return if 0 is less than r is less than the number of rows, and 0 less than equal to c less than the number of columns. Okay, if not is valid at this position, then skip it. I guess also skip it if it's already seen. Okay. Now scene of I should probably do something like not possible if following position does not connect. So let's say the backwards. I need the backwards. Backwards is minus dr minus dc. If grid at nr and c, no, sorry, so that's the next street number. Okay, so that's the next street number, so delta is of that number if the back traversal is not in I don't think this is correct. Not in. That's correct syntax. That doesn't. I don't know. Is that correct syntax? Not in. Okay, yeah. Back not in that list of things, then just return false. Okay, and then I guess I should probably just do, this is kind of stupid, huh? Okay. I guess in that case, and then I say scene of n, r, and c is equal to distance plus 1. And then something like next is equal, no, I guess current is equal to nrnc and distance plus 1. And I guess here if I say if rows equal to rows minus 1 and column is equal to columns minus 1, turn true. Okay, and then this should never return, but this should never hit, but just put that there anyways. I think this might work. I say that and this is probably just gonna crash. Deltas, that's fine. Scene, that seems fine. I have a current tuple. Unpack the current tuple. If the ending, return true. Get the street num. Guess I could just, it's only used once, so generally like to decompose my variables, but whatever. At this point, I think it's somewhat reasonable to read this. For every direction, there's only 2 directions. Find the new position following that direction. If it's out of bounds, or if I've already been there, I guess, okay, scene should just be true or false, huh? Yeah. No point making it. I don't actually need to know the distance, I just need to know if I've been there before. Or scene. Scene is true. Then skip it. Okay. Alright, I think here this should probably just be seen as true here. And I guess I just need to know the position at that point. I don't need to worry about the distance. Lots of edits. I don't know if I need to have the tuples, to be honest. Oh, I probably need to clean up just a little bit more. Interesting. Four, 1, 6, 1. Oops. 4, 1, 6, 1. 4, 1, 6, 1. Huh. 4, 6, and then 2 1s. So this thing goes this way. This thing goes this way. So it should return true, maybe. Do. 4, 1, 6, 1, right, should return true. But mine went totally out of bounds, or out. 0, 0. I see, I see. All these examples, I thought there was just going to be one path, but there could be two. It starts with like this, if it starts on this loop. I see. Yeah, there can be two paths. Okay. So maybe I should actually have a queue, huh? So that I can explore both paths. Okay, fine. Say a process queue. And then row column is going to be the first thing in the queue. If it's the ending position, return true. For every possible movement from that street type. Assuming it's valid and it's not already seen. Assuming that the next position also, okay, this can't return false immediately. Cannot return false immediately. So if this thing just should skip. And then seen, otherwise seen is true for that position, and then process appends that position. And then if there's nothing else to process, then return false. Okay. Oops, forgot to remove my test return. Okay. So I guess I just didn't, all these examples just threw me off. Also, I wasn't thinking hard enough. Okay. Alright, I think I can do a hack to not have to check what is valid each time. I can have a border around the scene that's all true, so that if it checks that position, it's just gonna be true. It's gonna have like a block. So scene is gonna be add a false, a true at the border. So for every row, actually for every row, scene row and scene.append true, and then S row, and then scene.append a row of trues. I think this should work. Add a border of true around the scene to prevent out of bounds indexing. Okay, so now I don't have to check for is valid NRNC. Guess I could combine these two. If already done, if backtracking, or if following position does not connect back. No, what am I doing? Okay, that's fine. Slightly weird spacing. This is very weird spacing. Right. I think that's fine. All right, I think that's as good as I'm going to try. Okay, so for summary, map position of distance, map position to if seen. This is just matrix to remember previous positions. All right, so summary. So what's the thing here? Kind of a simple traversal, path traversal problem. Use a scene matrix to keep track of previously entered positions. Use a delta mapping to get the movement possibilities by street number. So map street number to kind of list or set of DRDC, where DRDC is the change in row, change in column. Possible set of possible DRDC. Use a process queue to store positions to try to move when processing. Unpack the tuple to row and column. Check for end condition. If it's the last, return true if last kind of position. Then iterate over possible movements based on grid or based on street type, street number at that position. Check that the new position has not already been seen, and that the movement for that position can link back to the current. So IE has negative dr, negative dc within the set of movements at that position, at that new position. That if that works, then add that position to the queue and set its scene to true. Okay, I mean, that's, I don't know when the last time I just wrote that paragraph like that, but yeah. You have your delta mapping the street number to your list or your set of possible movements, DRDC. You have your scene matrix mapping position to true false if it's already been done. This is just a hack to prevent it from going out of bounds, indexing out of bounds. And then you have your process queue. You set your scene to true for your first position. Process each loop. Each loop you process a position. Check the end condition. If it's not that, then iterate over the possible movements from this position. So grid at row column is the street number, delta is at that street number, maps to the set. And then find the new position. Make sure the new position hasn't already been seen, and the new position links back to the previous position. So the street number of the new position has a set of movements that includes the backwards movement from that to this. And then, yeah, everything else is pretty straightforward, right? And then timeplex lets me O of n, where n is the size of the matrix, size of the group. Since each position can be traversed at most once, there's no kind of double backing over positions because of the scene matrix. Space complexity, this can be O of n. Well, is O of n or O of 1 actually? Yeah, actually it's O of n, since we use a scene matrix to keep track of previous positions. The actual process, doubling a queue, I think it only has 2 at any time. I'm pretty sure. So this process is always constant, but the scene is obviously